Somewhere in our galaxy, right now, there is an object the size of a city that could kill you from across the solar system. Not a black hole, not a supernova, something smaller, something stranger. It's called a magnetar, and most people have never heard of it. First, you need to understand what a neutron star is. Take a star 20 times the size of our sun. Let it burn for millions of years. Then let gravity win. In less than a second, the core collapses. Everything that was a star gets crushed down to a ball roughly 12 miles across. That is smaller than most cities, but it still contains more mass than the sun. A teaspoon of neutron star material weighs about 1 billion tons. If you drop that teaspoon from waist height, it would fall through the Earth like it wasn't there. That is a neutron star. A magnetar is what happens when something goes wrong during that collapse. Most neutron stars have magnetic fields, powerful ones. A magnetar's field is 1,000 times stronger than that. We are talking about a quadrillion times the magnetic field of Earth. That number is almost meaningless. So let's make it real. If a magnetar appeared where the moon is right now, it would pull the iron out of your blood before you had time to notice. At half the Earth-Moon distance, every credit card on the planet would be erased simultaneously. At 1,000 miles, its magnetism would begin pulling the atoms in your body into long needle-like formations. The laws of chemistry would stop applying to you. There are no magnetars anywhere near us. That is the only reason this is an academic conversation. On December 27, 2004, a magnetar named SGR 1806-20 had what astronomers call a giant flare. Its crust cracked, its magnetic field shifted, and in 1/10 of a second, it released more energy than our sun produces in 250,000 years. The light from that explosion hit Earth from 50,000 light years away. It ionized our upper atmosphere. It made Earth's magnetic field ring like a bell. It blinded several satellites. Several instruments on Earth recorded it not as a distant astronomical event, but as a disturbance in our own sky. Astronomers said it changed the ionosphere from night to day. That is what a magnetar does to a planet from the other side of the galaxy. Researchers calculated later that if SGR 1806-20 had been within 10 light years of Earth, it would have severely damaged our atmosphere. The nearest star to Earth is 4.2 light years away. There are only about 30 confirmed magnetars in the known universe. They are hard to find because they don't announce themselves. Most sit silent for years, sometimes decades. Then something shifts. The crust of a neutron star is not soft. It is the hardest substance that can exist. A steel wall is warm butter by comparison, but even that crust eventually cracks under the strain of a magnetic field trying to tear itself apart. When it does, the star screams. X-rays, gamma rays, radio pulses spiraling through space like something trying to send a message. In 2024, a telescope in Australia detected a magnetar that had been dormant for years suddenly reactivate. The signals it was sending were unlike anything astronomers had recorded. Circularly polarized light spiraling as it moved through space. They had no clean explanation. In March of 2026, astronomers witnessed something that had never been seen before. A star 25 times the mass of our sun died. A supernova. Bright enough to be one of the most luminous explosions ever recorded. But instead of fading normally, the brightness pulsed. 4 separate oscillations, each one coming faster than the last. After months of calculation, the researchers published their conclusion. They had watched a magnetar being born in real time. The spinning, the magnetic field, igniting the star's death, still feeding energy into the newborn object. It had never been observed before. The universe had let us watch. We live in a galaxy full of objects we cannot see and barely understand. Most of the time, that is fine. The distances are enormous. The silence holds. But once, on a quiet December morning, a star on the far side of the Milky Way shifted slightly. And Earth noticed. Not through telescopes, not through data, through the atmosphere itself. the sky changed. That is what a magnetar is. Not a theory, not a number on a page. Something so extreme that space itself carries the bruise.